The chapter is Quadrilaterals for Standard 9 and Part 2. Now in this figure, it is given the bisectors of angle A and angle C meet at P and Q here. Now we have to prove angle P plus angle Q is equal to half of angle BAD and BCD. So it is given this is a bisector, that means these two angles are equal. So we will put it as 1. And similarly, CQ is a bisector. So we will give this as 2. So what is given? Given AP and CQ are bisectors. So now we have to prove this. So consider the triangle quadrilateral AQCP. In quadrilateral AQCP, you know sum of all the angles of a quadrilateral is 360. So we can write, so this is angle 1. So angle 1 plus angle Q plus angle 2 plus angle P is equal to 360. Now consider the triangle QCB. In triangle or triangle CQB. CQB, we can say angle 2 plus angle Q plus angle B is equal to 180. In triangle now CQB, now we will take APD. In triangle APD, we will say, we can say AP and D, we can say angle 1 plus angle P plus angle D is equal to 180. Now we will add these two equations. So adding equation 1 plus equation 2, we will get angle 1 plus angle 2 plus angle Q plus angle B plus angle P plus angle D is equal to 360. So now let us write P plus Q is equal to, now angle P plus angle Q is equal to 360 minus angle Q plus angle D plus 1 plus 2. So angle 1 plus angle 2 plus angle B plus angle D. So everything I have taken to this side and put a bracket over here. Now we know A plus B plus C plus D is 180. So angle A, so this is equation 3, let it be here. So angle A plus angle B plus angle C plus angle D is equal to 360. So we will write C plus D is equal to angle C plus angle D is equal to 360 minus A plus B. Angle A plus angle B. Now angle A, we can write it as twice angle 1 and B can be written as C plus D. Sorry, we have to write B plus D. Sorry, B plus D is equal to angle A minus angle C. So this 360 minus angle A can be written as twice angle 1 plus C can be written as twice angle 2. So this is equal to, so we will substitute this in this. So substituting 4 in 3, we will get angle P plus angle Q is equal to 360 minus angle 1 plus angle 2. Now plus B plus D is this. So plus 360 minus twice angle 1 minus twice angle 2. Now this is equal to, now if you open the bracket, simplify here, 1 minus, this will become minus and 2 minus angle 1 minus twice angle 1 will become, so I'll write it down. So that will be, now we have 360 over here, then 1 minus 2 is minus angle 1, again this is minus angle 2. So again you open the bracket, 360 and 360 cancels, 1 minus and minus, and again here minus and minus will become, this is equal to angle 1 plus angle 2. So angle 1 plus angle 2, so we can write this as angle 1 is half of BAD, angle BAD plus half of 2 is angle BCD, so angle BCD. Now we are going to prove the properties of the parallelogram which we discussed in the previous part. So a diagonal of a parallelogram divides it into two congruent triangles. So it's given ABCD is a parallelogram. So ABCD is a parallelogram is given. Then we have to take the basic property of a parallelogram, that is if AB is parallel to CD and AD is parallel to BC, then it is a parallelogram. So we have to take only this to prove these properties, because this is a basic property of a quadrilateral to be a parallelogram. So now we have to prove triangle ABD is congruent to triangle BDC. For this, now we will join BD. Now we will consider these two triangles. So triangle ABD and triangle BD, ABD and CBD. So we'll start writing. We have AB is parallel to CD. From that we can say these two angles are alternate angles. We will give these angles angle 1 and 2. So angle A in ABD, angle 2 is equal to angle 1. So that is, the reason is, we will write this is angle. The reason is, here AB is parallel to CD. Alternate interior angles are equal. Now we have BD as common. So BD equal to BD is side. It's a common side. Now you can say this. Now these two angles are equal because AD is parallel to BC. See, if you draw like this, that form a set. So 3 is equal to 4. Angle 3 equal to angle 4. For that, the reason is AD is parallel to BC. Again, alternate interior angles. Now we have A as A. The two triangles are congruent. Now we can write it as A, triangle ABD is congruent to triangle ABD is congruent to CBD. Triangle CBD. Now from that you can say ABD means which is equal to 1. So we have to write CDB. So triangle CDB. From this we can write AB is equal to CD. ASA congruence. From that we can write, now we have to simply prove ABD is congruent to BDC. Now from this we can write AB is equal to CD and AD is equal to BC. AD equal to BC. That is CPCT, that is congruent parts of congruent triangles. So we have the next property, opposite sides are equal. So we have proved this also from this. So here from this we can say the opposite sides of a parallelogram are equal. So when you have this question to be proved, you will have to write all this, and then after this you have to write this and say the opposite sides of a parallelogram are equal.